Good.
Good. So what are we doing? What are we working on tonight?
Just some like solving the triangle.
Okay. Go ahead and give me the specifics.
Yeah. So it says angle A equals 52 degrees.
Okay.
C equals 29 miles and A equals 27 miles.
What was C again?
29 miles.
And A?
27 miles.
Okay. When you're talking about triangles, it's useful to distinguish between capital and little. Okay? Capital usually refers to an angle. Little refers to a dimension. So we're looking at this. Notice that all those angles are capital letters. That's little a, and that's little c. So, how do we solve this? What's the number one thing you look for to solve a triangle that's not a right triangle? Which law? The law of what?
The law of sines.
Yeah, you can always use the law of sines when you have an angle and its opposite side. The moment you have that, that triangle is solved.
Okay.
Okay, so give me some equations that will let us fill in the other three pieces.
Okay, so 27 over the sine of 52 equals 29 over the sine of x.
Not x, but c.
Or c, yeah.
Okay, because there's a couple of unknown angles here. We got b also.
Okay.
Okay, so go ahead and solve that. What do you get for the sine of c? I'm assuming you know how to solve that.
Yeah.
Okay, what's the sine of c? Not c, but what's the sine of c equal to?
0.84.
What would it mean if that number was greater than 1?
There couldn't be a triangle.
Exactly. In other words, sines and cosines can never be greater than 1. So when you're solving a triangle and you end up with the sine of one of the angles being greater than 1, you know it's an impossible triangle. So what is c equal to? If the sine of c equals 0.84, what is c equal to?
57.14 degrees.
Now, this is a situation where you could potentially have an ambiguous triangle. Do you know what I'm talking about?
Not really.
In other words, there may be a second triangle that fits all of those requirements, and it would be a different triangle. What would that triangle look like? It would look like something like this. Notice, still have a 52-degree angle, still have 29 side length, and I still have 27 side length. Yet that blue triangle is a second triangle. It's completely different than my ABC triangle.
Okay.
Okay? Now, this is the only hard part about the law of sines and, frankly, the law of cosines. Is this ambiguous triangle when regarding the law of sines? Let me give you a very, very simple way of figuring out whether this is ambiguous or not. What is the other solution for C besides 57.14 degrees? Where else is the sine of C equal to 0.84? What is supplementary to that angle? In other words, we know the sine of C is positive in the first and the second quadrant, right?
Yeah.
So there's actually another angle that satisfies the sine of that angle equals 0.84. What is it? What's supplementary to 57 degrees? It's always that one. It's always the supplementary one.
123.
Okay. I would rather they use whole numbers myself, but they don't. So
Okay.
we'll use that. Now, here's the thing. At this point, you have to try to figure out if both of those answers are possible. We can certainly have a 57-degree angle at C.
Yeah.
Can we have a 123-degree angle at C? Yes, as long as the sum of the three angles do not exceed 180. Well, this totals 175.
Okay.
So what that means is the following. I'm going to draw the blue one outside so that I don't confuse. Here's the other triangle. Still ABC. That's still 29. That's still 52. Only this one is 123, we'll call it, rounding everything up. Okay? Well, if that's 52 and that's 123, that still leaves 5 degrees for that one right there.
Mm-hmm.
And that's still 27. Notice we still have a 52-degree angle, we still have a 29, and we still have a 27, but it's a completely different triangle.
Yeah.
That's what you call the ambiguous case of the law of sine.
Okay.
And the only thing you need to do to check, it's usually when you're dealing with side-side angle, like this one. Side-side angle. Okay?
Okay.
When you have side-side angle and you go to calculate angle C, just like we did, always figure out what the supplementary angle is, and if that fits in there, then it's a solution. If it were to come out to be 130 degrees instead of 122, well, then I can't have a 130-degree angle there because I already got a 52-degree angle. You get it?
Yep, I do.
Okay. And that's the easiest way to solve it. I've seen pages in trig books where they gave you a whole page of stuff to memorize as to whether or not this was going to be an ambiguous triangle. And I found it very difficult to memorize all that stuff. And then when I came upon this method, oh, this is so much easier. It's just whenever you come up with that angle, always figure out the supplementary angle and then see if it's possible that you could have that 122.86 degrees. And you can in this case. In other words, the two angles do not exceed 180. If they exceeded 180, like let's say that came out to be 130, that's not a solution then. And the only solution would be that one.
Okay.
Okay? All right. What else you got?
So this one is angle A equals 47 degrees, C equals 34 miles, and A equals 33 miles.
Okay, little c equals 34, little a equals 33. It is important to distinguish between little and big.
Yeah.
Okay, you can't just say A, because that's
Okay.
A. But since they are giving us a triangle that has a big A and a little a, we need to distinguish between the two. Okay, so
Okay.
again, we have our primary consideration is we have an angle and we have its opposite side. That always tells us how to start this problem out. This time I'm not going to draw it, the triangle. Just go ahead and start with the law of sines.
Okay, so 33 over the sine of 47 equals 34 over the sine of C.
Solve that for the sine of C. What do you get?
0.75.
So what is C? In other words, now we're solving for the angle. What is it?
48.59 degrees.
And what's the supplementary? Always solve for that also.
131.40.
Now, the only angle we know is this 47-degree angle. Is there room for both of these solutions?
Yes.
Yes, there is. What you do is you always add that one to that one. If they exceed 180 degrees, then that 131 is not a solution. The only solution becomes the smaller angle. But if they don't exceed 180, then there is room for all three angles. In other words, this thing looks like this. There's one solution. That's 47. I'm going to round these off. I really don't know why they do this. It makes it so much more difficult to even talk about. This is 34. This is 33. Okay. So one solution, let's see, those total 96. That means this is 84. And then we could clearly figure out little b, okay? Using the law of sines also. Now I'm going to draw the second solution. Same angle. Same sides. Only this one goes this way. And that's 33. And this angle right here is what?
49.
No, it's 49 over here. This is a totally different looking triangle. Notice that that's an obtuse angle always. So it's got to be this angle that we just calculated.
Oh, okay.
Okay? That's the way it works. That's 131.4. This here, still 47. That still leaves me 1.6 degrees for this one right there. And then again, I've got to calculate side B. It's going to be a different little b. Just like angle B is different. The only thing you have to realize is this triangle has the same starting conditions as this triangle does.
Okay.
Angle A is 47, side C is 34, side A is 33. It's when this adds to this and it exceeds 180 that you do not have the ambiguous case. You only have this one. You would not have this one.
Yeah.
But that supplementary angle added to that starting angle A has to exceed 180. Otherwise, you do have two separate solutions.
Yeah.
You're going to need them. If you're taking a test and you only give this solution, you're going to lose points for sure.
Okay.
Like I said, this is the only hard part of law of sines or the law of cosines. It's the only hard part about it. Everything else is plug in and solve.
Yep.
This part's a little tricky, the ambiguous case. It's the only thing I've ever seen give anybody any trouble. Okay, what do you got? You got a third one? It'd be nice if they give us one that isn't the ambiguous case. In other words, where there's only one solution, but they give it to us how they give it to us.
So this one is angle B equals 12 degrees, angle C equals 16 degrees, and little a equals 34.
I'm going to draw this one. Hey, not very good. Let me draw it again. Let's see. We got B is 12. That's really small. We got C is 16. That's really small. Does that fit? Okay. Let's solve it. It's the first thing we need to do. Can we use the law of sines right out the get-go?
No.
Correct. We need an angle and its opposite side. So what are we going to do here?
Law of cosine?
No, don't really need that. That's a good option. You could solve it that way, but there's actually a much easier way to solve it. Do you know what angle A is?
Oh, yeah. You could subtract those two from 180.
152, I think, yeah.
Yeah.
So angle A is 152. Now we can use the law of sines. So give me an equation.
34 over sine of 152 equals A over the sine of 16.
Not A. What is opposite angle C?
B.
Little c, always, by definition. What's opposite angle B? Little b.
34.
No,
Yeah.
little b. Okay, here's the way you find the side that's opposite an angle. Okay, there's B, draw it. What 2 points does it connect? Side B. Doesn't matter how it looks. It's what 2 points do those rays connect? They create side B. Therefore, B is opposite angle B.
Okay.
Okay? It's not just because they're the same letter. That's also the convention we use, is that little b is always opposite angle B, and little c is always opposite angle C, and so forth. But sometimes it can be a little tricky figuring out which side is opposite which angle. This is kind of a weird triangle here. It's not immediately visible as to which side is opposite angle B or C. So just draw those rays, connect it, whatever side you get, that's it. So what's the rest of this equation?
Equals C over sine of 16.
Okay, that's a number, that's a number, that's a number. What's C equal to? Little c.
Uh, 19.96.
Okay, and what is little b? In other words, we now have 3 angles and 2 sides. You always have to come up with all 6 dimensions, all 3 angles and all 3 sides in solving a triangle. So what's little b equal to? What's the equation that lets me solve for it?
34 over the sine of 152 equals B over the sine of 12.
Good. What's B?
5.1.
Now, let's check to make sure that we're ballparking it. What does that
Okay.
mean? Ballparking it, when I say that with a triangle, it means, do we have the biggest angle opposite the biggest side? And do we have the smallest angle opposite the smallest side? Because that always has to be true in a triangle.
Mm-hmm.
Okay? That's a theorem. If you have three different angles and three different sides, the biggest side is going to be opposite the biggest angle, the smallest side is going to be opposite the smallest angle, and the middle side is going to be opposite the middle angle.
Mm-hmm.
Well, 16 degrees is opposite 19.96. 12 degrees is opposite 5.1. And 152 degrees is opposite 34. So it passes that test.
Yeah.
And I don't know of any other test to give it. As long as you've done your math properly on solving those two equations, that's the correct answer. But
Okay.
had we gotten a number like 25, can't be.
Okay.
Okay? Because then we would have 25 opposite a 12-degree angle and 19.9 opposite a 16-degree angle. You can't have that.
Okay.
All right. What else?
Okay, so this one is angle A equals 32 degrees, little a equals 17 centimeters, and little c equals 5 centimeters.
Uh-huh. Now, they've only given you 3 pieces of information, and they've only given you one angle, which means we can't automatically come up with that third angle.
Mm-hmm.
However, we got an angle, we got an opposite side. What law are we going to use?
Law of sine.
Okay, give me an equation.
17 over the sine of 32 equals b over the sine of 100,
Not B,
or not b, c,
which is 5.
yeah, so over the sine of
Sine of
c.
what? Sine of capital C. C, it's hard to tell, but this is little c, this is capital C. Okay, so solve that for the sine of C.
And you get 0.15.
Solve that for C.
And you get 8.62 degrees.
And give me the supplementary angle. That's always part of the process. Always.
Mm-hmm.
Even if you don't even think it's ambiguous, give me that supplementary angle.
171.38.
Is there room for that in this picture? What do you compare it with to find out?
Angle A.
That's the only one we know for sure is in the triangle. Okay? Can you have a 32-degree angle and a 171-degree angle?
No.
That means that one is ambiguous. Or not ambiguous, that one can't be.
Yep.
So we only have this solution right there. In other words, we've got angle C. 8.62 degrees.
Yep.
Now we got angle A, we got little a, we got angle C, we got little c. We don't know anything about B. So what's the next step?
You can use law of sines again.
Well, first of all, we need to figure out what the angle B is. In other words, you can't use law of sines if both numerator and denominator are variables. So we need to figure out what angle B is. We can do that. We know what angle A is. We know what angle C is.
Yeah.
So what is it?
It's 139.38 degrees.
Okay. Now, how do we figure out side B?
So you could do 17 over sine of 32 equals b over the sine of 139.38.
Good. And that will give you a number for B. In other words, that's a number, that's a number, that's a number. So you can figure out B.
Yeah.
Side B. Well, I'm glad they gave you this problem because at least this illustrates when it's not ambiguous.
Mm-hmm.
And notice that the test is pretty easy. You don't really have to remember anything else. You don't. This full page in my book of things you're supposed to remember when you have an ambiguous triangle is completely unnecessary. Because all you need to do is always to figure out that supplementary angle. Once you figure out that supplementary angle, see if it fits in a triangle with the only angle they've told you is in there, 32 degrees. In this case, it does not. Therefore, it's not one of, in other words, this is going to yield a unique triangle, not two different solutions. It's going to have one solution only. Now, before we move on, because we're running out of time, let me real quickly cover this point. You're using the law of sines, or cosines as far as that matters, and you go through all your calculations and you get the sine of C equals 1.01. What does that mean?
There can't be a triangle.
There cannot be a triangle with these three measurements. In other words, the way you discover that is by trying to solve for it using the law of sines. And the first thing you discover is that the sine of some angle is greater than 1. That's impossible. Sine of an angle can never be greater than 1. Cosine of an angle can never be greater than 1. So when you get greater than 1, you know it's an impossible triangle. Okay? And you will find some like that, where, you know, if they tried to tell you you can have a triangle that's 2, 2, 5, you can't. Oh, yes, you can. You can't have a triangle. What am I thinking? No, this 5 side has to be less than the 2 plus 2. So you cannot have a triangle 2, 2, 5. Okay? And you would know that from that basic rule that says any side of a triangle has to be less than the sum of the other two sides or greater than the difference. Well, 5 is not less than the sum of 2 plus 2. So if I gave you this triangle and said solve it, you would have ended up getting something like this.
Okay.
You would have gotten the sine of an angle is greater than 1. And that tells you that that's an impossible triangle.
Okay.
And same thing with the law of cosines. We didn't cover the law of cosines tonight. Law of cosines is actually a little bit easier because you don't have that ambiguous case.
Yeah.
In other words, as long as you can remember those three formulas for the law of cosines and when to use it, then it unfolds very simply as an algebraic equation that you have to solve.
Yep.
You do not have that difficult concept of ambiguous triangles when you're using the law of cosines. You pretty much have to use the law of cosines if you cannot use the law of sines. That's kind of the rule. Okay? In other words, if I go back and make that a B instead of an A, well, then I have an angle and I have two sides, but I don't have an angle and an opposite side.
Yeah.
So what does that tell me? That tells me I got to use the law of cosines. In other words, if you cannot start the problem with the law of sines, you got to start it with the law of cosines.
Yeah.
Even when you use the law of cosines, step 2 is always going to be the law of sines. So you're always going to complete the problem using the law of sines. But first of all, we got to use the law of cosines to come up with a fourth piece of information. Because if we know angle A and we know side B and side C, we cannot use the law of sines. There's no relationship there between an angle and its opposite side. And that's when you use the law of cosines, and there's one other situation where you have side, side, side. That's the only other situation where you use the law of cosines.
Okay.
Okay?
Yep.
Vid, you good to go?
Yep.
You have a good evening. I'll talk to you next time.
Thank you.